My name is Scott Davis. I'm CEO and co-founder of Vescent. And today I'm going to talk to you about lasers and photonics tools for quantum systems. I got my 4+ minutes. It's a little bit like speed dating with customers. Your operative word is speed. So let's just get into it. What are we about as a company? What is Vescent about as an organization? At our core, we manufacture products that enable quantum systems in the photonics laser-enabled quantum space. And we've been doing this for quite some time. We've been doing this for about 15 years. When we started 15 years ago, a standard quantum lab was quite complicated. There's a picture of Ketterle's lab from a number of years ago. It's a sea of optics on a vibration isolated optics table with a group of grad students keeping it going. We manufacture systems for that make that easier. So in the middle is a research and development system. It's a 4-laser system. It's dramatically simpler than it used to be. We also manufacture products that enable deployed quantum OEM products. So for us, we are about the full laser solution. That means sources, stabilization, and control. It's more than just the laser. A lot of our products are JILA and JQI inspired. We come out of JILA, a bunch of us. JQI is the Joint Quantum Institute. Things like Liebig Hall laser drivers with sub-shot noise, current noise, PI2D laser servos and offset phase locks. Jan Hall taught us the importance of that second stage of integral gain. At a JQI, we've commercialized a fast and very quiet piezo servo. All of this know-how across our electronics and our optics products is incorporated into both our laboratory products and our OEM products. And so what do I mean by OEM products? Well, one of the reasons I get up in the morning is I am excited about quantum leaving the lab. This has been a long path for me, all the way back from grad school. We are in the beginning and in the middle of that. And so here's an example of a field-deployed quantum laser engine that we manufacture. This has applications for clocks, computers, sensors, and we cram a tremendous amount of functionality into here. And so in this one offering, we've got 2 lasers, gas reference, beat note detectors, 4 laser drivers, 6 temperature controllers, bandwidth, high-speed bandwidth. It's a lot. And I will say that when you're looking at it from an actual deployed system, the drivers of SWAP are not the optics and the lasers. It's everything else that you need to get your photons to do what you need them to do for your quantum application. And we are looking at it from a whole system solution. That's not to say that the optics aren't important. So inside all of this are the optics. So here's an example optical core of an OEM module for a quantum laser engine. This has 4 stages of isolation, 2 lasers, a sub-Doppler spectroscopy module. It's a whole optics lab in your palm. I will point out the importance of isolation. Quantum has frequency requirements that are much, much harder than telecom. It's much more sensitive to optical feedback. This is a big issue. I will also point out the gas cell. This is a big issue. We manufacture these in our Golden, Colorado facility in telecom-style micro-optics assembly, and these are designed to just work in an OEM situation. So we've got a unit that's been deployed in a clock running continuously for greater than 3 years. I'm quite proud of that. We also manufacture turnkey frequency combs. Frequency combs are, as folks know, amazing devices. They're amazing, enabling, they're worthy of the recent Nobel Prize. They're used for disciplining multiple lasers, optical clocks, sensing. We now manufacture frequency combs that are truly turnkey, almost like an oscilloscope. You buy it, you turn it on, it locks up, you're ready to go. We have laboratory units. We also have units and versions of units, OEM units that we sell to customers. There's an example of an OEM oscillator. That's the heart of the comb. We've got progress on rad-hard versions. We have oscillators in a dual comb spectroscopy system that was deployed in the field in Oklahoma during a recent deep freeze, and it survived that. It's quite proud of that. We are feeding the quantum supply chain. And so this is across timing, computing, sensing, communicating. We develop and commercialize technologies that are low swap, easy to use, deployable, volume scalable, and designed for quantum. And we're not standing still. In addition to what I talked about, we also are working on watt-level CW lasers from the near IR to near UV, ultra-narrow line width lasers that enable deployed quantum clocks, which is coming. Laser systems for quantum are hard. I get that. We've been doing it for 15 years. let us manufacture the laser system for us. Give us a call. Here's how to contact us. Like I said, we're in Golden, Colorado, sales@vescent.com. Go to our webpage. We got a line of international distributors. Folks know how to contact me. That's it. I'm out of time. Thank you.
Vescent has a history, also a very long history, even from the foundings of the company, getting into technologies around enabling quantum, right?
We do indeed. One of our co-founders, the chairman of the board, was as a postdoc. He was the first one that did a Bose-Einstein condensation there at Cornell's lab. Kurt Vogel, our VP of R&D, was instrumental in early frequency combs and early optical clocks. Yeah, it's in our DNA.
Yeah. So you you started Vescent, and you immediately started, continuing to supply into people doing quantum research. You started, supplying tools, laser sources, clocks.
We started Vescent for an alternate technology that I was leading. We eventually sold that off, but we needed to make money. We had mortgages to pay. And so we started making products that we know how to make. And those were things like laser servos and laser drivers and stuff we learned how to do in grad school. And it's really grown as an evolution from that. We are very much, I'm back as CEO for a little over a year now, and we're pushing towards manufacturing, OEM applications, getting things out in the field. We're having super fun.
So can you go back to your slide where you show that crazy optics table that we see in so many quantum presentations?
Yeah.
So looking at the center picture, I think a lot of people have questions. Well, when is quantum going to get out of the lab, right? And so in that middle picture there, can you talk a little bit more about that? I mean, that's Vescent moving beyond research and selling into development platforms and ultimately deployed platforms, which you're already starting to do in quantum, right?
That's right. And so this is a system. It's got 4 DBR lasers, and our DBR lasers are manufactured by Photodyne. They make great chips. Thank you, John and Annie. 4 DBR lasers, spectroscopy references for doing locking your hyperfine transition, all the offset locking electronics, all the heterodyne modules. This is a system that is for an atom interferometer. It'll also be used for certain types of clocks, for certain types of sensors. And the idea is all the drivers and everything are included in that relatively small system. But, this is helping customers develop and fine tune their quantum system. Then we're also working with those customers on figuring out what pieces of this need to be incorporated into an OEM module. That OEM module, then we will sell to them as these quantum systems leave the lab, which is
great. And then so given all that, we have time for maybe one quick question, quick answer. Where do you see sort of some of the first deployments going beyond what you've been doing so far that Vescent is going to support?
I think optical clocks are coming. I know optical clocks are coming. Those need combs. Those need sort of quantum spectroscopy level lasers. We're in the middle of manufacturing and providing those. And so that's coming in the near term. I think sensors are interesting. I think computers are still sort of mainframe lab systems. Time frame for getting those, as far as I see, most of the quantum computing is a services model, so they don't care as much about deployability. I think that will change in time, and I want Vescent to be a part of that change.
Great.
That's my
Thank you.